It's another tech day. As you all already know, before I really get into the work, before I activate my neurons, before I use 100% of my brain, I love to spend some time with the same brain running on a flowery meadow, so to say. And I like to play these relaxation games, so to say. And we will start with this one. Basically, the gist is I need to guess what it is. There are 6 guesses, there are six different clues. If I don't guess it immediately, as I go on and on, the clues become easier and easier. And there are some other games that I'm playing, and there are some other places outside of these ones that I can, do just some warm-ups, just a tiny little bit of happiness before I need to do what needs to be done. Okay, let us start. First of all, it's a wall, a broken wall. Now, some of you might think this could be anything, but my big brain says it's my big brain doesn't say anything. I'm gonna do a stupid guess. I'm gonna say this is Prince of Persia. The Sense of Time. It's not. Okay. A Metacritic score of 74. It's a street lamp with some cars, a foggy background, a foggy neighborhood. When could this have been released? Maybe somewhere around 2012. Even 2012 seems a bit. I have nothing. Just a broken wall. And my initial guess was that this would be a role-playing game, something similar to Skyrim, less known. But no, unless the orcs have invented electricity, I don't think it's Skyrim or anything similar. There's something blue here. I have no idea what. Some electricity pools. Okay, I need to skip. Maybe it's one of the Final Fantasy games. Final Fantasy. And now I play the game in which I need to find the most reasonable game in the franchise. Maybe this one? So it's not Final Fantasy. PS3, PC, X360. What is this, brother? 74, so it's no GTA. Maybe a GTA clone? Just Cause? Just Cause 2, maybe? Action adventure. Sleeping Dogs? 2010. What the hell is this? 2010. Is it the it's the Godfather, right? Okay. It's the Mafia game. Is it the Mafia? Yeah, it's definitely Mafia, but which one of the Mafia games? So it's Vito. Because it's Vito, it's not the first one, but it's either the remake of the first one or the second one. I think it's the second one. Yeah, it's Mafia. Never played any of the games in the series. And I'm so stupid for not realizing it earlier. I saw this shirt and I thought, oh, this might be Sleeping Dogs or something. These street lamps are so 20th century cool that I should have. And the electricity pulse. Damn. Alright. At least we guessed it. Let's do the next one. And the next one says absolutely nothing to me. There are some colors here, but I definitely haven't played this. Is this a train, like a moving train? in all others, in all other quizzes, no one guesses things on their first try. It's the first clue is always, oh, it's yellow, and then it does second clue, it's yellow and big, and the third clue is yellow and big, and it's shiny, and the fourth clue it's yellow and big, and it warms you, and then you realize, it's the sun. So the first one, I'm gonna skip it. 84%. So it's a platformer. It's a platformer without with a rope going from the top to the bottom, but I haven't played this. I need to skip another one. Oh damn, I did play this. Is this? Oh, is this? But there's no way this is Hollow Knight. I think Hollow Knight was a 90% game, right? No, of course it's not Hollow Knight, but action platform Metroidvania. They got me with this one. This looked like one of the characters from Hollow Knight, and this light also looked oddly familiar. But here I'm almost certainly sure it's not. Action platform Metroidvania. Now, 2024. I'm an old school gamer. I'm not following the state of affairs when it comes to the roaring 20s. And I have no idea what this is. I've seen. I'm gonna be stupid if I skip it. And 9 Souls. Okay, I would not remember it. I've seen some gameplay. I would definitely not remember the name of it. What can you do? Not sad. I'm not sad. Let's do another one. Now, if this ain't... I would be stupid if I say Max Payne. It's definitely not Max Payne. But I remember a specific scene in which you are tortured in a basement, and there are some stairs leading upstairs, but Max Payne was a lot more darker than this. Again, for my first guess, I have nothing. But I don't want to skip. So I'm just gonna type, even if I know it's not Max Payne. I'm gonna type it then. Yeah, it's definitely not Max Payne. Metacritic score 82. Is this another platformer? It is another platform. What the hell is this? I need to skip again. DS. Okay, now I'm definitely... It's not my type of music. Not that there's anything bad with DS games. I just never had one. I need to skip. Bucket. Oh, I think I know what this is. Okay. I need another guess, I'm sorry. Ace Attorney. Is it this one? She was holding a piece of paper. It's definitely one of the Ace Attorney games. Is it? Ace Attorney. Apollo Justice. 9999. Ah! Okay. I apologize to the lords on the far away land of Japan for not guessing this game. I love JRPGs, but I never had a DS, so tough luck. Let's do another one. I guess this. Wait. Play previous days. Let's do this one. Lots of barrels. PewDiePie wouldn't like this one bit. In relation to this, no, it's not called insomnia, amnesia. I'm gonna guess any one of these because I don't know which one it is. So it's not amnesia, but is it the third thief? Thief, Deadly Shadows. Thief, Deadly Shadows. It's not. PC, PS4, Xbox One. Who are these characters? Action role playing Find a Smuggler. 2019. Let me just go back to 72 Metacritic score. I need to skip another one. Developers, spiders. No, no idea. Greed Fall. Wow. Wow. Okay. Well, not my best showings, guys. Let's do another one. This one I need to guess. I have to guess this one. I need to because if I don't guess it, I can't really and happily start working. I would recognize this grass everywhere. No, I wouldn't. I have no idea what this is. So it's grass. Is it Red Dead Redemption 2? 88. There's a cattle skull here. So I was I close with my guess. Uncharted 4. PS5, PC, Xbox Series. Kingdom Come Deliverance. What year? 88. What? It's definitely Kingdom Come. Kingdom Come Deliverance. This is the second one. Nice work, guys. All right, the first two didn't ring any bells in my head. The third one was already I filtered out some guesses here. But with the fourth one, yeah, the fourth one was definitely a big giveaway. I remember the UI. Fifth one, I mean, the release date would tip me off definitely, and the sixth one, yeah. All right, yeah, let's do another one. I know what this is. No, I don't. But Persona 3. No, it's not Persona 3. Okay, Metacritic score 65. Sorry, it just reminded me, the first image reminded me so much of the Tartarus in Persona 3. But it's not. And the fact that it's a 65% game means that's definitely not. No. Skip. GameCube. So this is an obscure GameCube title. Action role-playing fighting game. No, brother. No, brother, 2004. What is this? Kill. Could be one of the Armored Core games. Custom Robo. Okay. No, I need to guess one. I need to guess one before I need to guess one. Wait. This. I'm guessing this one. 100% I'm guessing this one. Blood splattering all over the window. It's definitely not Super Mario. It's definitely not Spelunky. It's definitely not Stardew Valley. So I have those couple of games out of the way. Now, what could this be? Blood splattering like this. Is this even blood splatter? Let me do a guess. Let me do any guess and maybe it will. So something bloody. There's no way it's Call of Duty. There's no way it's Call of Duty. Call of Duty is so... What's the right word? Neutered? But I'm just gonna make a guess. Yeah, it's not Call of Duty. Is this even blood? 84. Sims? It's not Sims. It's on Switch and on PC. Okay, so it's a Switch exclusive. Visual novel tactical role playing. No, brother. No, brother. Not my best day. Okay, let's do. You know where I'm good at? At guessing the angle. I think I'm gonna guess the angle, and then I'm gonna start. So immediately 90 here. Here, this is less than 45. I'm gonna say it's 40. It's an even number, so it gives me a bit more space to think about. So it's not 40, it's less than 45. It's maybe less than 40. 180 plus. Let's say 40, 220. But I don't think it's 220. I think it's 216. Wow, it's even smaller than 216. Wait, is this 180? 90. 216. There's no way it's bigger than 210. It's definitely not bigger than 210. If it's bigger than 210, so I have two guesses in between, yeah. So I have 212 and 214. And let me do some mental calculations. 2 degrees is quite a big difference for the trained eye. For the untrained, yes, someone would say, oh, but imagine if your house was built and there's a 2-degree difference between lying flat on a slope of land and, you know, just collapsing. I think this is 212. 21. No, it could be 214. 212. And let's do another one. Only one more. Look at this. 2, 6, 8. All right, boys and girls. Let's do some work here. All right. Let's go back to the book. Structure and interpretation of computer program. There's an example right here. It says square roots by Newton's method. And it says the following. So what is the square root? We more or less, you most probably encountered the concept of square roots. If you haven't, then maybe don't watch this video. So the square root of x is y, such that y is bigger and equal than 0, and y is equal to y squared is equal to x. And this is a perfectly legitimate mathematical function. And with this formula, we can recognize the number of the square root, whether whether a number is the square root of another number, or we can derive facts about square roots in general. But is this telling us how to find square root of x? No, we can even write this in Lisp, in pseudo Lisp, to say define square root of x, and what is this? It's the y and it needs to be bigger and equal than y needs to be bigger and equal than 0, and the square of y should be equal to x. So what is the difference between the mathematical function and the programmatical procedure? Basically doesn't tell us how the mathematical function doesn't tell us the imperative knowledge, doesn't tell us how to actually derive the square root, because in mathematics we are concerned with the declarative descriptions, but in computer science we are concerned with imperative descriptions, or how to do it. And how does someone compute square root? Well, one of the most common ways is to use Newton's method of successive approximations, which basically says that whether we have a guess for the value of square root, we can perform another manipulation to get a better guess, which is closer to the original square root. So how are we doing this? Well, let's say we are looking for the square root of 2. And let's say at first guess is 1. And then you get the quotient, and this. And the quotient could be 2 divided by 1. 2. We make another column. Then I find the average of this. So it's going to be 2 plus 1. 2, it's 3, it's 1.5. So our second guess, 1.5. Now, we do the same thing. We divide 1 over our guess. And this will be 1.333. And then we do 1.33 plus 1.5 divided by 2, and this will be 1.4167. And our third guess is 1.4167. So our third guess, we just repeat the same thing here. and here, and we get more guesses, and we basically obtain better and better approximations to our square roots. This guy is 12 as well. Now, how can we write this process in the terms of programmable procedures? By the way, the thing is, because I was really interested in this, I was trying to understand how did Newton thought of this. And basically, as we said, finding a square root is just solving this equation. And basically finding the square root of y, or square root of x, pardon, is where the curve y squared minus x crosses 0. So I do this. This is the curve y squared minus x. So we need to find where this curve is crossing 0. And as we did here, suppose we guessed a value for the square root of x, and our guess, as we just shown here, is most probably wrong. But we can measure how wrong it is, and we need to ask ourselves, if I move in the right direction, how far should I move? So Newton's idea, when he discovered this trick, I mean, he didn't discover any trick. This is the, how do I say, the way square roots actually behave. And basically, if we have curve f(x) is, as I said, y squared minus x, and if we guess a value which is y0, at this point y0, we can draw the tangent to the curve and see where the tangent crosses the x-axis, and this crossing point is a better guess. Basically, this is just a pretty smart way to keep guessing better, and as you see here, we guessed 1 initially, and it's not right because 1 multiplied by 1 is 1, so it's too small. But we need to see how wrong the guess is. And basically, because I have 2 values here, my original guess and the value I get by dividing 2, because I'm averaging the values 2 with 1, I'm just averaging them. Yeah. And then we repeat the same idea over and over again. Okay. All right. So what we want to solve here, because we said we want to compute square roots, but instead of using the built-in math function, we're going to define the process ourselves. And we said we are using the Newton's method. We are starting with a guess, we are improving it repeatedly, stop when it's good enough. And the high-level idea is start with a guess. Check if the guess is good enough. If yes, we are returning this guess. If not, we are computing a better guess, and we repeat steps 2 or 4 repeatedly. And that's the entire algorithm. And we can create a procedure for this. Okay, let's try here. I'm just gonna do this quickly. I'm not gonna even this pseudocode. I'm gonna not be as detailed when it comes to indentations. I'm defining sqrt iteration. I have my guess and I have my x. If good enough, yes, x, I'm returning my guess. Otherwise, I'm calling the square root iteration again on an improved guess. Basically meaning if we have a guess and we have a number x, if the guess is good enough, we are returning it immediately. Otherwise, we are improving the guess and we are trying again. This is something called a recursion, but conceptually in this case, it behaves like a loop. So we have a high level overview of this. So how could we and how can we improve a guess? So how do we actually improve on a guess? So we need to define a method that improves a guess. And we can correlate it from the steps that we have here that we have done manually. So let me create and write pseudocode for the improve method. Okay. Right. If you can make the correlation here, we are dividing our initial x with our guess. And then we are looking for the average between our guess and the value that we got basically. As we keep averaging these numbers, they are pulling us closer to the square root. And what else? We just need to define the average. So this is a method that we are missing. Average. And what we were missing here, we missed improved and good enough. We're gonna create all of them. So average, what do we get? As our values x and y, and we should just return plus x y and then divided by 2. And one last method, it's called good enough. So we have our guess and we have our x, and we need basically to create a method that's saying the guess is good enough if the square root of the guess is different from x by less than a certain value. And how do we do this? So if I square my guess, I'm gonna get a value that should be close to x. So I need to compare it by x by subtracting it, but also I need an absolute value because the value can be both positive and negative. And then I'm comparing it against this value. So if if the square root of the guess is different by 0.01, is or less than 0.01, the guess is good enough. Okay. Now we have an exercise which is related to this. Basically says Alyssa P. Hacker doesn't see why if needs to be provided as a special form. Why can't I just define it as an ordinary procedure in terms of cont? She says. Alyssa's friend Eva Lou Ater claims that this can indeed be done and she can define a new version of if. And then we demonstrate it, and we can write the new if to rewrite the square root program. Okay. So how is this working? Okay, so we can define. So let me put it. We can define new predicate, then else. So this is the then clause and this is the else clause, and then I have the condition here. I have the predicate, and the then clause, and then I have else and the else clause. I have no idea what the hell I have written here. But wait here, someone wrote an example here. New if equals to 3.0.5. Okay, so this is predicate. This is the then, and the 5 and the 5. What? Okay, for some reason the 5. All right, so that works out. And the 5 is the else clause. So what it happens here, and I assume new if is checking against the predicate. And if the predicate is true, we are hitting the then. Otherwise, we are hitting the else. This should return 5. Other way, if we put here, for example, 1 and 1, it should return 0. So here it says Alyssa uses the new if to rewrite the square root program, but there's an issue in it. So let me write the square root program and see why or why not it will work. Can I just copy it somehow? I can copy it. Wait. It'll be easier than just writing all of it. add text box, then I copy here. For some reason it's black. I need to change the color, maybe into one. It's so much. Where's the color? Is it color? Okay, let me use green. Let me reduce the font size. All right. Cool. I have it here now. Amazing. So this is. I should also indent it a bit. All right, I definitely need to find a better way to do this. Definitely need to find a better way to do this. Let's move forward. Idea. Moving forward, I will definitely need to see how to improve this, but for now it's okay. So what happens when we use this to compute square roots, when we use this method? Can I write over this? Yes, I can. Okay, so why this will or won't work? It says, okay, let me try to create a mental map of this in my head. We have already on the right, we have our helper methods. We have our helper methods on the right. So what is happening here? Let's see. This is fine, and our guess. It's not good enough. Most probably it's not good enough. So we hit the iterator here. So what happens here? What happens if we run square root iterator for 1.2 and 9? So before calling this method, Lisp will evaluate all arguments. So this will hopefully be okay because we have all the values here. If we provided 1 and 9, it's going to be 1.2 and 9. But this line right here, because it's evaluated immediately, and we talked about this in the last stream, before new if even gets control, then it happens again. And again. And again. So if we solve this, we will get the next value of, or maybe we can use 2 here. And let's use 2 instead of 9. 2 and 2. So the next guess will be 1.5. It's going to evaluate here. Square root of iterator. Improve 1.5 to 2. It's evaluating again immediately, and the recursion never stops because good enough is never allowed to short circuit, and the base case is never reached. So that's why we need a conditional. That's why we need a conditional. Makes sense. Makes sense. Makes sense. let's do another exercise. Here it says exercises are the best. With exercise, you basically you are solving these examples on your own, and I think that's better than learning the book cover to cover, only learning the theoretical. So this exercises the good enough test used in computing square roots will not be very effective. Where is it? It's here. Is this one? So the good enough test used in computing square roots will not be very effective for finding the square roots of very small numbers. Also, in real computers, arithmetic operations are almost always performed with limited precision. This makes our tests inadequate for very large numbers. Why? Explain these statements with examples showing how the test fails for small and large numbers. An alternative strategy for implementing good enough is to watch how guess changes from one iteration to the next, and to stop when the changes are a very small fraction of the guess. Design a square root procedure that uses this kind of end test. Does this work better for small and large numbers? So why does the original good enough fail? This is our test. And here specifically it uses the absolute value to calculate the error threshold within 0.01 of x. So let's say we wanted to find the square root of 10 on the power of minus 10. And what is this actually? It's actually a number that has 0.0010 of these zeros, 1. And the square root of this number is 10 over minus 5. And this is 0.0001. And we had our original test, basically saying any guess whose square is within 0.01 of x is accepted. But if x is a really tiny number, then 0.001 is enormous to compare to x. For example, in this case, we were guessing if we were looking for the square root, we could have found a guess that was 0.01. And then we would use this formula right here. We would square the guess, and squaring the guess we would get 0.0001. And then we would subtract the absolute value from our real value. So our absolute value would be 0.001 minus, I don't know, 0.00 1. We should have 9 zeros. Our absolute value, and that's around 0.00000999. I don't know how many nines, 99999, let's say. And because this number is smaller than our threshold, it will stop. But this value, that was our initial guess, is a lot bigger than our real value, than the true answer. So for small x's, the test can stop very, very early, way too early, earlier than we would want to. So this was an example for very small numbers. For very large numbers, we have limited precision. So this makes the test impossible or very, very slow. Because for very large numbers, we have here the situation in which we have our guess squared minus x is less than 0.001. Okay, so very large numbers. What happens here? Real computers use finite precision floats, and around a very large number, the spacing between the presentable numbers is much bigger than 0.01. For example, a number such as 10 to the square of 20, let's say, and the square root is 10 to the square of 10. Basically, numbers that are this big can only be represented in chunks that are much larger than 0.01. And when we compute square guess, we get rounding, and we can get stuck where improving the guess doesn't change it anymore, because the new value rounds back to the old one, because it never becomes smaller than 0.01. And we end up looping because, okay, guess stops, the guess stops changing because of the rounding, and the absolute error never passes. So a better strategy is to stop when the guess stops changing, which is the relative change. Instead of checking is guess squared close to x, we should check, did the new guess change by only a tiny fraction compared to the old guess? And it scales well for both small and large numbers. And the only thing that we need to change here is we have here the iterative square method. We have the improve. Where is it good enough? The only thing that we need to change here will be this line. So most of the things are almost the same, but I'm comparing to the improved value. And I'm improving my guess. So this is how we actually create a better test, a better strategy. We are stopping when the guess stops changing relatively to the value that we set up. All right, let's make a quick stop here, and I'm gonna come get back at another time. Thank you. Bye bye.